Hello Internet, welcome back to Placement Buddies. Today I'll be continuing with the data structures and algorithm playlist. So I'll be discussing about the dynamic memory allocation, that is lecture 3. So let's get started with this. Before I am going to start the lecture, I want to apologize that I'm very much late on this video because I had to do my professional work. So I'm very much sorry for that. Before diving to the topic, that is dynamic memory allocation, let's understand how the memory organization works in C or C++. So as you can see in this diagram, there are three spaces in our memory section. That is, one is instructions or code, another one is text space, and another one is heap space. So how it actually works, we'll be looking at this. So first, going to the instruction or code space. This is basically a space for writing the code or instruction set to let the processor or the computer know what actually you want to do with the instruction, or let's say what you actually want to do with the data. Fine. And then stack space. This space is managed by the compiler for allocating and deallocating the memory. Let's say you have declared a variable, that is int a equal to 10 or int b equal to 50 or float c equal to 2.5. So these are the values will be stored in the stack. Or let's say you have defined a function, let's say add two numbers, and then it will be declared in this stack space. So this is managed by compiler. User or the programmer doesn't have any access to this space, that is stack space. So whenever we will be calling a function, it will be going to the stack space and it will be implementing over there, and then after implementing the function, it will just free the stack by using push and pop operations. Fine. And then another one is heap space. This is the space where the programmer or the coder will actually writing the data structure, or it will be manipulating the storage space as per the programmer's need. So this space is solely managed by the programmer for allocating and deallocating the memory. I hope this is clear. So let's do a quick recap of this. So there are three space. One is instructions and code space, where we can write the code or the instruction set to perform such certain operations, and then the stack space, which is managed by the compiler for allocating and deallocating the memory, and another one is heap space, which is actually managed by the programmer itself for allocating and deallocating the memory. Fine. So now let's discuss about what is actually dynamic memory allocation means and why do we need this. So as I have discussed, there are three spaces in the C or C++ memory organization section. So we'll be writing the dynamic memory allocation portion in the heap space. So whenever we write the data structure or any data over there, we need to remove it by us, because compiler doesn't take the responsibility to remove or free the space. So programmer has to be clear in his or her mind that the memory he or she will be allocating needs to be clear by them. Fine. So what is dynamic memory allocation? Based on elements we are storing and deleting, size of memory will be increase or decrease. That means in the runtime, let's say we want to create an array and this will be storing 10 values, but in runtime you will be needing 20 values. So you can just simply go to the code and do the size of that is 20, and then you run the code. It will be a like overhead for the programmer, and it won't be efficient way, because every time an user comes and new things need to be added, then programmer has to rewrite the code, and this is not a optimum solution. So the optimum solution is at the runtime we can increase or decrease the size of that particular memory or the chunk of that memory. So the idea comes from there. So there are four functions: malloc, calloc, and realloc and free to use this dynamic memory allocation. So what does the malloc, what actually calloc does and realloc does, we will be seeing in the next slides. And free is basically to free the memory segments. Fine. One important thing, that whenever you want to write a code or a program by using dynamic memory allocation, you have to include this library, that is #include stdlib.h. Okay. What is malloc? Malloc is nothing but a system inbuilt or inbuilt function provided by the C or C++ compiler to the programmer to write the code or programs in the heap space. So how it is declared in the C++ or C compiler. This is nothing but a void type of function which takes the size of that particular chunk of memory, how much the size we will be allocating. Then how it allocates, on the success it returns base address. That means the first address it is allocated for that memory. Fine. This is nothing but the pointer which points the starting location. And on the failure, that is if there is no space left, it will be indicated a null pointer. Fine. One example is, let's say I want to declare 10 space. What is 10 space? That is the 10 number of blocks. So simply I will be declaring a int type of pointer or any other pointer. Let's say for example I have taken int, that is int asterisk pointer equal to int star or int asterisk malloc space into size of int. That means I will be going through one by one. What does this means? Fine. So int star ptr, this means I have declared a int type of pointer and then I'm assigning it to the this whole chunk of memory. So what does this means? Int asterisk, that means I have typecasted this malloc from void to the int type. Fine. And then I have used the space into size of int. That means it will be allocating 10 spaces with aligning with the size of int. That means the number of bytes the int type of data type or int type of pointer will be required. Fine. This is compiler dependent. Let's say in 64-bit machine it will be needing 4 bytes and in 32-bit machines it will be needing 2 bytes. Fine. And in the result it will be allocating 10 memory spaces of int type and with garbage value. That means it won't be initialized with any other zero values. After declaring the memory chunks with the malloc, it will be some random values generated by the compiler. Fine. So calloc is nothing but the same as built-in function by provided by the C or C++ compiler. Fine. How it is defined? It is defined similarly as void asterisk, that means the void type of pointer it will be indicating, and then size tn, that means the size of or the space, how much chunks of memory you will be allocating or you want to be allocated, and then size, that means how much size of that particular one chunk it will be needing. Then how it's allocate, nothing but on success it will return the base address of that memory block, and then on failure, that means if there is no memory space present, it will be returning a null pointer, and then it initializes memory with the value. This is the key difference between the malloc and calloc. Fine. So this is the example how we will be declaring a calloc or the memory space. Fine. Let's say I have declared the size as int space, that is 10, that is 10 chunks of or the 10 space of memory block will be assigning, and then int asterisk ptr, that means int type of pointer we will be allocating, and this is also we have typecasted because the calloc is nothing but the void pointer, and then space, that means how much space we will be needing, and then size of int, that means how much size of a particular pointer will be needing to acquire. Fine. And on the result it will be returning the 10 memory spaces or the 10 blocks of memory of int type with the value 0. That means it will be initializing the value with 0. So what is realloc? Realloc is nothing but inbuilt function provided by the C or C++ and is defined as a void pointer, and the parameters or the arguments will be passing the pointer or the location we have initialized or declared by using malloc or calloc function, and then the size by which we want to increase the size of that array or the particular data structure. So how it will allocate? It will just simply points to the increased memory location. Let's say you want to increase the size of an array from 10 to 50, so it will be simply pointing to that 11th location as we have traversed up to 10. Fine. And if there is no space available, it will be simply returning a null pointer. And one example, that is we want to increase the size by 50, and then the pointer will be then declared as, or like will be assigning the pointer as int asterisk, that is we have typecasted because it is a void type of pointer, and then nothing but realloc ptr, that means earlier it is declared pointer or the memory, and then the size. So the result will be increased size of that allocated memory by 50 space. We'll be looking into this when we'll be writing some codes in our hands-on practice tutorial. Fine. So what is free? Free is nothing but a function that is also provided by the compiler to just free the memory. There is nothing much described over there, and the function definition and the function declaration is beyond of the scope, so it just frees the pointer. So let's discuss. So what we'll be discussing is one of the question I was asked in my interview. So the problem statement is like that: you are given a function. The function is memory allocator. Now you have to implement a memory allocator that supports a specific hardware requirement. What is the requirement and what is the function? We will be looking into this. The function is something like that: void asterisk memory alloc. That means a memory allocator function. You can be resemblance as the similarly malloc or calloc. This is nothing but a generic function that is memory alloc. This allocates a memory. The argument passing is void asterisk ptr. That means a void type of pointer. Okay, you don't have to bother about the implementation of the memory alloc. You just need to know that this is the function how you can allocate a memory. What is the hardware requirement? This is the most interesting part of this question, or the main part of this question. So all the allocated memory space need to be aligned in such a way that it is multiple of a provided number n. That means size modulus of n should be equal to 0. And the complete the function, you have to complete the function that is void asterisk memory alloc aligned. This is nothing but the code section. So I'll simply brief you how to proceed or what is the actual problem statement. Let's say you have declared one memory location, that is 100, by using that memory alloc function. So now you want to align the next memory location, which will be divided by that n. Let's say the n is 4. Okay, so now 1000 can be divided by the 4, but what will be the next location? Next location should be 1004. We know, but how you will be calculating this? How you will be assigning this? And one more thing you have to keep in mind, that if you are assigning this as like you are declaring this function and you are aligning this memory blocks or the chunks of memory, you have to keep in mind that if user requests 10 bytes of memory, or let's say 100 bytes of memory, you have to return him or her the 100 bytes of memory. You will be seeing how much the memory will be deteriorating or something. You have to take care of this. So this is a very interesting one, and you will be like, you have to work a lot with this, but the solution is a simple 2 or 3 lines of code. Fine. So if you want to do this, you can do this by yourself, or if you want me to discuss on this question, so you can just write in the comment section. So I'll be discussing about this code, and this is a very interesting one. So I was asked to solve this in my interview. I hope you will be able to do this, and don't worry if you aren't able to do this. I'll be doing this by myself and show you. Fine. So you can write the review in the our comment section. Till then, bye bye.